Welcome to Robots Are Not Boring.
Have you ever wondered how high a line follow sensor should be mounted? Well, this video might help you decide.
This robot has been designed to investigate the best height for line following sensors. We will look at line followers with one sensor and line followers with two sensors. The height of the sensors above the floor can be set to 1, 2 or 3 units. The WRO black line is 2 centimeters wide with 3 centimeters white space on each side. First, we need to see how the light intensity varies from white to black and back to white again. The robot has been modified to drive straight across the line and monitor the light intensity from the two sensors. To monitor the reflected light, the height of the sensors above the floor can also be set to 1, 2 or 3 units. We'll start with line followers using one sensor at 1 unit above the floor. To make it easy to read the line graph, I record also 3 fixed variables at 100, 0 and -50. I have lifted the green line graph to show where the sensor is passing over the black line. The purple line shows the reflected light from the sensor varies from 99 to 30% as the sensor moves from white to black. The red line is the error signal for the line follower. This is the sensor value minus the line follower set point, which is halfway between the reflected light value for white and the value for black. The error signal is equal to 0 halfway through the transition from white to black. The line follower can be programmed to follow the left side of the black line, where it will operate in this part of the curve, or the right side, where it will operate in this part. Here we compare the reflected light and error signals for sensors mounted at 1, 2 and 3 units above the floor. We can see that with the sensor mounted 1 unit above the floor, the light intensity varies quickly from the maximum level to the minimum level. At 2 units above the floor, the change in intensity is spread over a larger distance. At 3 units, the change is spread over an even larger distance, and we see that the maximum intensity is lower. The slope of the 3 error curves is different. This will affect the value of Kp, the multiplier for the line follower. We will now test the robot by driving over a junction and looking at the performance. First with sensor height 1 unit. Now 2 units. And finally 3 units. The proportional line follow factor Kp was adjusted for best performance in each case. When the sensor reaches the junction, the reflected light falls and then immediately rises as the line follower tries to reduce the error signal to 0. In all 3 cases, the line follower recovers from the disturbance. I would say 2 units looks the best. It's less jerky than 1 unit and has a stronger sensor signal than for 3 units. A 1-sensor line follower will drive along the border between the black and the white parts of the line. If it starts off to one side, it should be able to pull the robot back into the middle. We can see from the line graph that if the sensor is fully on black or fully on white, it should still pull the robot onto the border between black and white. The yellow arrows show the pull-in range. This will be the same for sensors at 1, 2 and 3 units above the floor. Here the sensor is 2 units above the floor, starting fully on white. And here on black, you can see that the robot pulls nicely over to the border between black and white. We can see this better in slow motion. The height of the sensor doesn't make much difference. Now we'll move on and look at line followers using 2 sensors. The difference between the sensors forms the error signal for the line follower. The robot, therefore, will follow the middle of the black line where the 2 sensor signals will be equal. We will now look at the signals from both sensors as the robot drives across white, black and white again. The 3 fixed variables on the line graph are at +100, 0 and -100. As before, the green line is raised in the area where the sensors are passing over the black line. The yellow and purple line graphs show the reflected light for the 2 sensors. The red line graph is the error signal for the line follower. It is the purple sensor minus the yellow sensor. This line graph shows the situation where the sensors are mounted 1 unit above the floor. If the robot is further from the center than these 2 points, then both sensors are on white, the error signal is 0, and the line follower cannot function. These points are 2 centimeters from the center, between them, the line follower will do its best to follow the line. Here we can compare the sensor signals and the error signal for the 3 different sensor heights. We see straight away for one unit, there is an area in the middle where both sensors have the maximum signal. This will not be good for the line follower. It's interesting to see that the slopes of the error signals are very similar, so we can use the same value of Kp for all 3 heights. The line follower pull-in range is at least 2 centimeters in each direction. Now we need to do some test runs to decide which height is best. First with the sensor 1 unit above the floor, now 2 units, and finally 3 units. We can see that for a sensor height of 1 unit, both sensors are more or less on the maximum signal and the control is sporadic. For 2 units, the line follower tries to make the 2 sensor signals equal and thereby stay on the middle of the black line. For 3 units, we can see that the sensor signals are much weaker, but the line follower still manages to control to the middle of the black line.
So what can we say after all this testing? Well, with sensors mounted 1 unit above the floor, a 1 sensor line follower works okay, but a 2 sensor line follower doesn't work well because of the dead band. With the sensors mounted at 3 units above the floor, the sensor signals are weaker, but line followers with 1 or with 2 sensors do function. With the sensors mounted at 2 units above the floor, I got the best results for 1 sensor line followers and for 2 sensor line followers. So this is the height I would recommend.
If you found this video useful, please like and subscribe.